Hey girls, I hope you are doing well. In this session, we'll work on coding using transfer learning. So sit back, relax, and let's build something cool. Before we start, make sure to open the Google Colab link. Then you're going to tap on File, and you're going to save a copy in the drive. Once you do that, it's going to open this window, and to make sure that it works, going to read here, it's called Copy of Transfer Learning. Why did we do that? Mainly, this allows you to make your own editable copy, so you can play around, change the code, add photos, and test without affecting the original version. So it's always better to keep your own copy so you can go back to it at any time, even after the session ends. And once your copy is ready, you're all set to code, test, and explore. So let us begin. Now, our example for today is making a robot to teach our friend and help her to identify different dishes. In particular, we're going to be using Lebanese dishes as an example. However, you can use any type of dish. Now, let us dive into the code. So as you can see, the first step is installing the Brain tool. I have already ran the line of code, so let us talk more about what it does. However, before that, you might be wondering, what is Google Colab? Google Colab is a free notebook on the internet that lets us run Python code. And of course, do not worry in case you don't know a lot of Python, I'll be explaining every step along the way. Now, imagine this line of code. It's like getting your cooking tools before making a dish. So before we teach the robot anything at all, we need to install TensorFlow. It's like downloading the brain that will actually do the learning for us. And it's just one line, and Google Colab does the rest. So it's pretty simple. Now our second part is uploading our food photos. It's also very simple, only 2 lines of code. Now what does it do? This is when we bring in our food photos, but not one by one. We put them all inside a zip file, and once we upload it, it's like telling the robot, here are the pictures, you need to learn them and open them. Now what are the pictures and how are we going to use them? As you can see here, we have this line of code, and it's actually a comment. You're going to copy it and place it here. And once you open it, you're going to get this Google Drive, and you're going to tap on this button to download the zip file. After you do so, you're going to upload this folder, and as you can clearly see, it was saved to LebaneseDishes.zip. Then we're going to run this code. And as you can see, we got an error. Why? Because we have to fill this line of code. It's not filled yet. So here it's a zip file. However, we need to actually unlock it and open it to be able to organize the dishes neatly in a folder, right? So now the computer needs to open the folder. What does it include? Our folder includes 3 files. We have hummus, 5 pictures. We have shawarma, also 5 pictures, and tabbouleh. In case you're wondering what it looks like, let's open this one. It's a random photo of tabbouleh. Now, what we need to do is to extract these photos. So we're going to use extract all Lebanese dishes. Then we're going to run it again, and it actually worked. Now let's run this line of code. Again, we have an error because we need to fill this part and this part as well. Now, before doing so, let us understand what we have to do in this part. So, as you can see, in this part, we need to clean and organize the images, right? So, we are creating a data generator. So, think of it like a kitchen helper that washes, resizes, and organizes the photos for us. We're going to put here the scale, something, a certain number, or a proportion. For our case, we're going to include 1 over 255. And this means that we're changing the image from 0 to 255, and it's going to become from 0 to 1, because computers are really fond and really like small numbers, just like how babies start with soft food. So it's better to rescale it. Now here, the validation split, we're going to put it as 0.2. And why did we choose this number? This means that we save 20% of the data for testing. So it's kind of like how we taste test food before serving it. It's the same. So now, because we chose 0.2, 20% of the set of the photos are going to be used to be testing if the computer is getting better. So it's the validation set, and 80% of the images are going to be used for learning. So it's training set. And here you can see it more clearly. It's training and validation sets. Now let's try to run the code again. And we have found 12 images belonging to 3 classes and 3 images belonging to 3, right? Why did we get this number? Because in total we have 15 images. So 20% of 15 is 3 and 80% of 15 is 12. So these images are going to be used for training and these images are going to be used for validation. Now we're going to run this part of the code, and in this case we are using a smart model. What do we mean by that? Imagine you have a cousin who's already amazing at recognizing cats, dogs, and cars from photos. Instead of teaching a baby, which takes time, you teach your cousin a new skill, which is in this case recognizing Lebanese food. And in this case, the cousin, we can call him Mobile Net V2. And it's a smart model that is already being trained on millions of images. So we're going to tell it, don't forget what you already know. And let's make sure to add a new top layer. So let's make sure that you can actually also recognize hummus and kibbeh. Now to identify these layers, you can think of it as a burger where you have the meat, the sauces, and the top bun. Or you can also take any other example. And mainly, our new model being built is like making a new dessert using ingredients from a classic one. So we have our base, which is our smart cousin mobile net. So this one. We have the pooling. This part is going to squish the image info down to the best parts. And we have finally the dance, which is going to allow us to make the final decision in this case. So it's going to tell us this looks like hummus or this looks like shawarma. Next, we're going to prepare the model for training, right? However, again, we have a problem. This needs to be fixed, and this part as well. Let us start with the optimizer. The optimizer in this case is going to be Adam. Adam is a smart way to learn. It's very fast, it's efficient, and it's going to help us in this case. Now we also have the loss. The loss is going to help the model know how wrong it is. And why do we care about that? So that it can actually improve. For the metrics, we need to measure the accuracy. So we're going to write accuracy, and it's going to help us see how good it's getting. After we run it, as you can see, we have our first epoch, which is like a round. And we do this for 2 rounds. The more epochs, so the more rounds, the better it's going to learn. But we're going to keep it small for now because in case we make the epochs larger, then it's going to take us more time. Now, before we continue, I would like to point out a very important thing, which is here, we said that we're going to use a smart model, right? So it's smart because in machine learning, we usually call a model smart when it has already been trained on lots of data and has already learned how to recognize patterns well. So in other words, it's going to be smart because it has knowledge from previous learning. So it can actually make good predictions without starting from scratch. For example, here in our case, it's mobile, not V2, that you have mentioned already. So it's really important to use a smart model since you're borrowing its experience to help your robot learn faster and better with less data. Now let us go back to where we were talking. So this part, preparing and augmenting image data. Now let us think about these two lines of code. Mainly what you're doing is that you're setting the rules for how the robot is going to learn. So Adam, the optimizer, is going to help it understand and actually improve itself. The loss function is going to measure the mistakes, and the accuracy is what we are going to keep track of. Now to go back to our results. As you have mentioned, it's two epochs, right? So two rounds. Now, what does it tell us? First, we have the accuracy, which is in the first round 16%, then it became 50%, which is higher. So that's good. The model has improved. 16%, it means that the training data, the model guessed correctly about 16% of the time. Then in the second round, it guessed around 50%, which is better. Now for the loss, it's around 1.2, then it became less, it decreased. So we got a number of 0.96. This means that the model's average mistake score on training data, it still made some significant errors, however, it's less on the second round. We still have our validation accuracy and our validation loss. So this accuracy, the validation accuracy, is actually the accuracy on the validation data. So the photos the model tests itself on, but didn't actually train with. So here it got around 33% correct. Now for the validation loss, so this part, this is mainly the model's mistake score on validation data. And this is mainly the results we got in this two rounds. Now we need to actually test it and make sure that the robot is actually identifying correctly. After we run it, we get this button, which is choose files. So we're going to choose a picture. So we open the shawarma folder. We're going to tap on shawarma 2 and we will wait for it to be uploaded. It's very fast. Now, what we have done here is we have given the robot a new photo that it has never seen before, in this case, a shawarma. And we have allowed it to actually see it and try to identify it. Now, how can we know if the robot actually is working correctly? We're going to run this line of code. We got an error again. Why? Because this part is not words. So we have to fix it. What are we supposed to enter? As you can see, we have imported NumPy. We have a certain image. Now here it's .jpg. So we need to actually replace it with the name of the file. In this case, with the name of the photo, which is saved as shawarma 2. Do we have other points? No, that's it. So we're going to run it again. And it told us that it's probably shawarma. Now, What did we do exactly? Let's break this into tiny pieces. First, we have loaded the image and we have resized it, right? Then we have converted it into numbers. How did we do so? Using this, dividing it by 255. Then we have predicted the label and we have finally printed that it's probably going to be, in this case, shawarma. So it's like giving your model a mystery dish and asking it, do you know what this is? And then it tells you, well, it's probably going to be shawarma in this case. Now, just to be sure, we're going to run this line of code. We have here a space, so we need to fix it. What are we supposed to import? Before typing the answer, let us see what this part actually does. So as you can see here, it has correctly predicted the shawarma. However, it's always better to visualize our results. So just to be sure, we're going to show the picture and the robot is going to tell us what it thinks it is, right? So we're going to put here matplotlib. Let us run it and we can see the actual photo of shawarma. So the lines of code have actually worked with us, and let us discuss a bit what we have done. Mainly, we uploaded and organized the food images. We used transfer learning to teach a smart model something new. We tested it here with one photo. We can test it with several photos. And then we saw it guess correctly the dish. And this actually works with any kind of dish. So you can do your own types of dishes. You can use any kind of folders with the photos, and it will actually work all of the time. So the final analogy that you need to remember is that the transfer learning is like teaching your smart cousin or any one of your friends one more thing. And instead of learning it from scratch, you build on what you already know. So just like you who already knows how to study, how to maybe dance or cook, learning a new thing gets way easier. I hope you benefited, and I would like to thank you for being so focused and finishing this video. I hope you have a great day so far, and that's it.